GATE 2018 Civil Engineering Set 2 Question 35. A car follows a slow moving truck traveling at a speed of 10 meter per second on a two-lane two-way highway. The car reduces its speed to 10 meter per second and follows the truck, maintaining a distance of 16 meter from the truck. On finding a clear gap in the opposing traffic stream, the car accelerates at an average rate of 4 meter per second square, overtakes the truck and returns to its original lane. When it returns to its original lane, the distance between the car and the truck is 16 meter. The total distance covered by the car during this period when it leaves the lane and subsequently returns to its lane after overtaking is. The four options given are A 64 meter, B 72 meter, C 128 meter and D 144 meters. The relevant NPTEL reference has been cited. So when we talk about overtaking maneuver on a two-lane two-way highway, we can see that there will be a passer which intends to pass the vehicle at the front, but it is not able to pass since the vehicle is traveling at a slower speed. So sometimes what they do is they will slow down at a speed equal to the slow moving vehicle's speed, and they will travel for a reaction time of TR. This is because they may not be getting a clear gap in the opposing traffic stream. So they will travel a distance of d1 with a speed of the impeding vehicle's speed, that is the slow moving vehicle, into its reaction time. Once it has judged in its reaction time that the gap is available, it starts the overtake at this point and encroaches the opposite lane and comes back to its lane. While doing this maneuver, it maintains an initial gap of S from the impeder, and after finishing the maneuver, it again maintains a final gap of S. During this time, let us call it capital T for the maneuver, the impeder would have also traveled a certain distance. So D2 will be given as 2S plus B, where B is the distance traveled by the impeder, that is the slow moving vehicle. And while this happens, since it is a two-lane two-way highway, we also need to mind the opposing vehicle. It would have traveled by the design speed into the capital T time that has taken for the maneuver. So if we compare D2, that is 2S plus B, it should be the same as the initial speed of overtaking for the passer, that is Vi, and it would use the T time plus half of AT square. This is the same as second equation of motion, where a body starts moving with a certain speed of u and uses an acceleration rate of a for the time t and covers a certain distance. But here we can see that that distance is equal to 2s plus b. So if we compare these two equations, we will see that b is equal to vi into capital T, where it is the distance traveled by the impeder in t time. So b and vit gets cancelled out, and t would be finally obtained as root over 4s by a, where s is the safe spacing and a is the acceleration rate of the passing vehicle. On adding these three components together, we would get OSD, that is given as d1 plus d2 plus d3, that is the overtaking side distance on a two-lane two-way highway that must be provided so that a faster moving vehicle can pass a slower moving vehicle safely against the traffic in the opposite lane. So in this case, it has been given in the question that we need to consider the part of the maneuver when it leaves the lane to when it comes back. So we don't need to count the oncoming vehicle or the initial reaction time phase. We only need to consider this phase, that is the d2 distance, for our calculation, because this is the time when it encroaches the opposite lane and this is also the time when it comes back. So only d2 component needs to be found for our case. We can see that d2 is nothing but 2 times of s plus b. In the question we have been given s as 16 meters, which is the same initially and after the completion of the pass. The acceleration rate has been given as 4 meter per second square, and the truck, that is the impeder, is moving with a speed of 10 meters per second. So d2 can be written as 2 times of s, that is 16, and b would be the same as u times of the maneuver time capital T. So u is given to us as 10 and we need to find T to compute d2. So T, as we saw in the previous slide, is given as root over 4s by a. Substituting the values, we would get 4 into 16 by 4. This would turn out to be 4 seconds. Substituting the value of T here, we would get d2 as 32 plus 40, which turns out to be 72 meters. So 72 meters is the distance that the passer will use when it leaves the lane and comes back to its own lane, while maintaining a safe spacing of s, that is 16 meters, from the slow moving truck. So the total distance covered by the car during the period was 72 meters, which is option B. The relevant NPTEL reference has been mentioned.